So we're going to be able to find the other zeros knowing that one number already gets you to 0. Let's set up the synthetic division. So -3 is what gets us to 0. So -3 goes into the box. And then 2, 11, 18, 9, these are the coefficients from the polynomial. So you bring down your first term. And then we're going to multiply anything below this line by the boxed number and write it in the next column. So we get -6 when we multiply 2 times -3. We write it below the 11. After multiplying, we're going to add. Then we multiply, write it in the next column, and then we add. So multiply, write it in the next column, and add. We got a 0 as the remainder, and now we're going to be able to find the other zeros. But the way we're going to find the other zeros is recognizing that now I can rewrite this polynomial. This polynomial has a factor of x minus -3. And then the rest of it is this, 2x squared plus 5x plus 3 plus no remainder. So I just cut it off there. And I'm going to be able to find the other zeros using old strategies, multiply, add, or quadratic formula, something. So let's zoom in on 2x squared plus 5x plus 3 and recognize that, okay, what multiplies to 6 adds to 5. Wait, where did I get the 6? You got to multiply these two. If we use the bottoms up strategy, we get x plus 2 over the leading coefficient 2 times x plus 3 over the leading coefficient 2. We simplify, and we're finding the zeros. After we simplify, all right, what's going to make each one of these zeros? Because we're trying to figure out what are the zeros. So what would make this set of parentheses 0? What would make this set of parentheses 0? Point of this is to find the other zeros. So if we use synthetic division using the information given in the problem, it cuts down to the other factor. Well, wait, if we start out with a cubed term, then the other factor will go down 1 in its degree, and so on. So the other factor can either, I don't know, ironically multiply, add worked with this. Sometimes it might be quadratic formula. We just got to keep that in mind. So let's try this again. We're going to find the other zeros. We're going to find the other zeros of this polynomial, knowing that 2 is one of the zeros. So it's written in a different format. If I know that 2 is a 0, I'm going to set up synthetic division with 2 in the box. Following the synthetic division rules, bring down your first term, multiply by the boxed number, so we get 2 and then add, and then multiply by the boxed number, and then add, multiply by the boxed number, and add. We should get 0 as a remainder because the directions say one of the zeros should be 2. So if for some reason you did not get a 0 in that remainder, you know you did something wrong. So let's figure out how can we redo this polynomial. It can be rewritten as x minus 2 times 1x squared plus 0x minus 9. So I could rewrite it as x squared minus 9. And we're going to zoom in on that other factor. The other factor, x squared minus 9, you've got to ask yourself, how can I find the other zeros? So we could either factor to figure out the zeros, saying x minus 3x plus 3, or we could use the square root method, add 9 to the other side, take the square root on both sides, and include the plus or minus. So the other two zeros are positive 3 and negative 3. So if that's what we're figuring out in our homework. This is where we stop for homework today. On Tuesday, we're going to go one more step further and write the factors. We're going to concentrate on the difference between these direction words. How if you have a direction word that says factor, that means I want my answers looking something with parentheses. If the direction said to find the zeros, I'm looking for values. So that'll be more Tuesday.